In this video, we'll be working on how to find the limit of a function, mainly a rational function. We have to find the limit of this function when x tends to negative infinity. First of all, it's a rational function. Then, x is tending to infinity. If we replace x by infinity in the numerator and denominator, we will have infinity in the numerator and infinity in the denominator, which is an undetermined form. Infinity over infinity is not determined. Then we have to think about a way in order to find the limit of this function, which is a rational function, as x tends to infinity. If you look at 2x and negative 1, they are negligible in front of 4x cubed. And the same in the denominator, if we develop, we have 3x cubed, and the other terms are negligible in front of 3x cubed. And then we have a rational expression and x is tending to infinity, which is leading to undetermination. Then we take the limit of the leading terms. The leading term in the numerator is 4x cubed, as we said, and in the denominator is 3x cubed. Then, by simplification, simplifying x cubed and x cubed, we have 4 over 3. So the limit of this function as x tends to negative infinity is 4 over 3. What can we deduce? Since the limit of this function as x tends to minus infinity is a constant, 4 over 3, then y equal 4 over 3 is an horizontal asymptote. In part B, we have to find the limit of a rational function as x tends to 2. If we replace x by 2, we have 4 minus 6 plus 2 over 4 minus 4. 4 minus 6 plus 2 is 0. 4 minus 4 is 0. So the answer will be 0 over 0, which is also undetermined. We have to get rid of undetermination by factoring the numerator and the denominator. Why we are thinking of factoring? Because the 0 in the numerator is coming from a factor that is x minus 2, and also in the denominator we have the factor x minus 2. Then we take the roots of the numerator and the roots of the denominator. The roots of the numerator, if you find delta and the roots, or you use your calculator, they are 2 and 1. So the numerator can be written as 1, because the coefficient of x squared is 1, into x minus 2 into x minus 1. The denominator is a difference of two squares. We have 2 minus x into 2 plus x. This is the factored form. But now we don't have a common factor. We need to get the common factor. The denominator, 2 minus x, is the opposite of x minus 2. So this is 2 minus x. It's minus into x minus 2 because it's the opposite of x minus 2. So I can write the function as limit of x minus 2 into x minus 1 over minus x minus 2 times 2 plus x. We simplify the factor x minus 2. By this, we are removing the factor that is leading to 0 over 0. And our expression will be, our function will be x minus 1 over minus 2 plus x, as x tends to 2. We replace x by 2. 2 minus 1 is 1. 2 plus 2 is 4. We have minus 4. So the answer is minus 1 over 4. In this part, we don't have asymptotes because the limit of the function as x tends to a constant is not infinity. It's a constant. In this part, we have also a rational function, and we want to study the limit of this function as x tends to 3. If we replace x by 3 in the numerator, we have 0. In the denominator, we have 2 minus radical of 4, which is 2 minus 2. It's also 0. We have 0 over 0, which is undetermined. We need to get rid of undetermination. I cannot factor the numerator and the denominator to have a common factor to simplify. In this case, because we have radical in the denominator, to get rid of undetermination, we have to rationalize the denominator. We multiply the numerator and the denominator by the conjugate of the denominator, which is 2 plus radical x plus 1. We simplify the denominator. We keep the numerator as it is. We don't mind about having the same form of the numerator. In the denominator, we have the square of the first term, which is 4, minus the square of the second, which is x plus 1. When we reduce, the answer is the numerator as it is, 4 minus x minus 1 in the denominator, which is nothing but in the denominator minus x plus 3. We notice that we have a relation between a factor in the numerator and the denominator, which is x minus 3, denominator minus x plus 3, opposite of x minus 3. We factorize the denominator by minus 1 to get x minus 3. Now, we simplify the x minus 3 with x minus 3, and the answer is limit of 2 plus radical x plus 1 over minus 1. We replace x by 3. 3 plus 1 is 4, so 2 plus 2, it is 4 over negative 1, and the answer is negative 4. So here in this part, to get rid of undetermination, we multiplied the numerator and denominator by the conjugate of the denominator, rationalizing. Then we factorized to get rid of the factor leading to 0 over 0, and we got the answer. Also in this case, there is no asymptote because the limit as x tends to a constant is also a constant. It's not infinity. Thank you.